we are discussing introductory part of probability. In the previous class, that is in part 1, I have defined some definitions to define definition of probability. Today, I will also discuss some terms to define probability. Now, event. What is event? What is event? Event is subset of sample space. An event is subset of a sample space. You know what is sample space? Set of all possible outcomes. So an event is a subset of sample space. So take an example. Two dice are thrown. We are discussing only the basic concept. Two dice are thrown. E1 equals to event of two heads. E2 equals to event of one head. E3 equals to event of at least one head. So two dice are thrown. So what is event? Event is a subset of sample space. So what is E1? E1 equals to event of two heads. So you know sample space is, try to recall, HH, HT, TH, TT. When two dice are thrown, this is sample space. Now what is event? Event is a subset of sample space. What is E1? Event of two heads. So two heads. So you are getting only one evidence. HH event. Now what is E2? E2 equals to event of E2 equals to event of two heads, and E2 equals to event of one head. So that is HT, TH. One head, here also one head. And what is E3? Event of at least one head. So at least one head means one head or two heads. So this is U1 into E3. Now next definition, exclusive event. Exclusive event. Exclusive event or disjoint event. Disjoint. So exclusive or disjoint. Now, two events E1 and E2 are said to be exclusive if E1 intersection E2, very simple definition, equals to phi. So no common member. So exclusive event or disjoint event, E1 and E2 are exclusive if there is no common element. So this is disjoint event. Now, in the previous example, E1 equals to HH, E2 equals to one head HT TH, and E3 equals to at least one head HT TH TT. Now we verify whether E1, E2 and E3 are exclusive or not. Now E1 intersection E2. Now this is phi. This is phi. There is no common member. So E1 and E2 are exclusive. E1 and E2. So we need this definition. Now what is E2 intersection E3? Now there are two common members, HT and TH. So not equals to phi. So E2 and E3 are not exclusive. E2 and E3 are not exclusive. Exclusive. Now what is E1 intersection E3? E1 intersection E2, then E1 intersection E3. So E3 is, this is HH. So you are getting two heads. This is common, not equals to phi. So E3 and E1 are not exclusive. So exclusive event. Now exhaustive event. Exhaustive events. Now what is exhaustive event? We take three events, E1, E2, E3 are said to be exhaustive. Exhaustive if E1 union E2 union E3 equals to S. So what is S? S is sample space. S is sample space. E1, E2, E3 are said to be exhaustive. For E1 and E2, E1 union E2 equals to S. For three events, E1 union E2 union E3 equals to S. So similarly, for n events, E1 union E2 union E3, if there are n events, this equals to S, where S is sample space. So these to be noted. What is exhaustive events? Now take an example. A die is thrown. A die is thrown. E1 equals to event of getting even number. So what is the event E1? 2, 4, 6. Now E2 equals to event of getting odd number. So 1, 3, 5. Now E1 union E2 equals to 1, 2, 3, 4, 5, 6. So this is sample space. So here E1 and E2 are said to be exhaustive event because E1 union E2 equals to S. So this is exhaustive event. So we take this definition to define probability. Now application. From a group, so it is already solved in case of sample space. From a group of 2 boys and 3 girls, 2 are taken. 2 children are taken at random. E1 equals to, both are girls. E2 equals to event of getting 1 boy and 1 girl. E3 equals to at least 1 boy. Verify হয়ে যায়। E1 and E2 and number 2 E2 and E3 are exclusive or not, or so to get E1, E2, E3 we need, so what is sample space? Sample space I have already stated 5 persons. So 2 are taken at random, so 10. If you are student of class 11, you know, and if you are student of class 10, so you calculate it in this way. So boys B1, B2, girls G1, G2, G3. So event of getting S equals to sample space first. Suppose two boys B1, B2, B1, B2. Two girls G1, G2, G1, G3, G2, G3. One boy, one girl, B1, G1, B1, G2, B1, G3, B2, G1, B2, G2, B2, G3. And look, boys 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 outcomes. So this is S. Now what is E1? E1 equals to, you look, both are girls. So you are getting G1, G2, G1, G2, G1, G3 and G2, G3. So 3 outcomes here. And what is E2? One boy and one girl. So one boy B1, G1, B1, G2, B1, G3, B2, G1, B2, G2, B2, G3. And number 3, add least one boy. Add least one boy means one boy plus two boy, because two are taken maximum at a time. So B1, G1. So what is G3? At least one boy. So at least one boy. B1, G1, B1, G2, B1, G3, B2, G1, B2, G2, B2, G3. Two boys. So B1, B2. One boy, two boys. So maximum two boys. So this is sample space. Now you have to verify whether E1 and E2 are exclusive or not. Now E1 intersection E2, obviously there is no common member. So this is 5. E1 and E2 are exclusive. Exclusive. E1 and E2 are exclusive. Now what is E2 intersection E3? E2 and E3. So look, there are many common members. How many? 6 common members. So E1, E2, this is not equals to 5. Because common member, there are 6 common members. So E2 and E3 are not exclusive. E2 and E3 are not exclusive. Now look here, this is, if you look E1 union E2 union E3. So E1 union E2 union E3. So if you take, you are getting the sample space. So E1, E2, E3 are exhaustive event. Exhaustive event. So what is event? Exclusive event. Then exclusive and exhaustive. Exhaustive event. exclusive and exhaustive event. So we get three events. So E1, E2, E3 are said to be exclusive and exhaustive. If EI intersection EJ equals to 5 and E1 union E2 union E3 equals to S. There is no common member, and if you add these events you get sample space. So look an example. So suppose this one is E1, this is E2, this is E3. Here EI intersection, there is no common member, but E1 union E2 union E3 equals to S. So this will be the case. E1 union E2 union E3 equals to S and EI intersection EJ equals to 5. Now look, if there is any common member, so this is not exclusive. This one is look, E1 union E3 equals to S and there is no common member. This is called exclusive and exhaustive event. So this to be noted. So we are discussing only the basic definition to define probability. Now I consider one more problem. Simplest problem. 2 dice are thrown and sum of the numbers which comes up on the dice is noted. So 2 dice are thrown. You know the sample space 36. So to find event you should have clear idea about sample space. So what is A? Sum is event. A equals to sum is event. Sum is event. So 1, 2, 3, 4, 5, 6. So event sum. So sum is event means sum is 2 or 4 or 6 or 8 or 10 or 12. Maximum up to 12. So to get 2, so only one cases, 1, 1. Sum is 2, first one is 1, second one is 1. Now 1, then 4. 4 in first row 1, 1, 2, 1, 6. So 1, 3. 1, 3. Then 2, 2. Then 3, 1. And 4, 1 there is no. So we are getting only 3 cases. Now 6. 6, 1, 5. 2, 4. 1, 5. 2, 4. 3, 3. 4, 2. 5, 1. So to get 6. Now 8. To get 8, 1, 1, 2, 1, 6, no. This one is 2, 6. 5, 3. 5, 3. 4, 4. So 2, 6, you write 3, 5. Then 5, 3. Then 6, 2. 8. Then 10. 2, 6. So 3, 6. 4, 6. 5, 5. And 6, 4. So we are getting 10 and 12. Only one, that is 6, 6. So this is even for A. Now B equals to multiple of 3. Multiple of 3. So what is B? Multiple of 3. Sum is multiple of 3. So multiple of 3, this is 6, 3 or 6 or 9 or 12. So to get 3, we are getting two cases. 1, 2 and 2, 1. To get sum as 6. So we have already considered it. 1, 5, 2, 4, 3, 3, 4, 2, 5. Then 9. 3, 6, 4, 5, 5, 4, 6, 3, and 12. 12 is 6, 6. Now what is C? C is sum is less than 4. Sum is less than 4. That is 2 and 3. So 2 and 3, that is 1, 1. 1, 2, 2, 1. So we are getting C. Now what is D? D equals to sum is greater than 11. Sum is greater than, so 11 is not included. Greater than 11. That is 12. So you are getting 6, 6. Only one cases, that is 6, 6. So we are getting the events. Now it is very simple. So you have to which pairs are exclusive. So A intersection B. Not equals to 5. B intersection C. B intersection C. B intersection C. Sum is 2 and 3. Here also 2. So this is not equals to 5. Now C intersection D. C intersection D. There is no common part. This is 5. This is 5. Now AB, BC, CD. Now what is A intersection D? A intersection D. So look, 6, 6 is common. Not equals to 5. A intersection C. So what is C? A intersection C. So sum, this is not equals to 5. A intersection D. A intersection D. 6, 6 is a common. This is not equals to 5. 5. Then BC, B intersection D. B intersection D, let us verify. This is not equals to 5. Now C intersection D equals to 5. So we are getting only A intersection C. A intersection C. What is A? 2. So we are getting C intersection D equals to 5. So C and D are exclusive. C and D are exclusive. So exclusive even. Then one more definition to define probability. This is equally likely outcomes. Equally likely outcomes. So if a coin is thrown, you know, head or tail will appear. Head or tail will appear. If the coin is not biased, that is equal chance of getting head and tail. Head and tail. Suppose for a coin having head and tail, having head and tail, if one face is uneven, then you cannot get. Suppose for a coin, one face is head and this is tail. If this is uneven, if it is uneven, then opposite face of uneven will not occur. So this is bias. Unbiased means each outcomes has equal chance of occurring. So what is equally likely outcomes? Outcomes of a random experiment is said to be equally likely if each outcomes have same preference. That is, no face has given to be have same preference. Each outcomes have same preference. For example, a coin is tossed. So what is pH? pH equals to half. What is PT? PT equals to half. So tossing of coin, or tossing of a coin, the outcomes are H and T are equally likely outcomes. For throwing a die, so of getting phase 1, 1 by 6, P2 1 by 6, then P6 1 by 6, P4 1 by 6, P5 1 by 6, P3 also 1 by 6. So this is, if you one getting phase 1, this is E1, then outcomes are equally lively. So outcomes of a random experiment is said to be equally lively if each outcomes have same preference. Same preference. No phases is to be given preference. That is, each outcomes have same preference. So today I have discussed only two definitions. So what is event? Then exhaustive event, exclusive event. So one, that is event. It is most important. Then one more definition, equally lively outcomes. Outcomes of a random experiment is said to be equally lively if each outcomes have same preference. Suppose a coin is tossed 10 times. You may get pH equals to 4 by getting head. So suppose coin is tossed 10 times and you are getting 4 heads, 6 tails. But it may happen. But if you perform the experiment large number of times, suppose 1000 times, then P head and P tail approximately equal to same. pH and P10 approximately equals to same. Now look, here pH and P10, pH and PT are not same for 10 times. But if it is repeated many times, the ratio of head and tail nearly equal to 1. So equally likely means there is no preference. That is, so a coin is tossed, coin is unbiased. We suppose that it is given or not, we suppose that it is unbiased. So today I have discussed only two definitions. So I have already discussed what is a random experiment, what is outcomes, what is sample space, event, equally likely outcomes, exhaustive outcomes. Using this definition, I will give classical definition of probability in the next class. So thank you.